Hi, hello everyone, welcome to this video. And last time we did our texture, right? And this time what we're going to focus on is bit on validation and debugging and how can we debug with WebGPU. With that said, we're going to cover debugger a bit later in this video, but let's just go and try to see how some stuff works with WebGPU. So the first very obvious thing when we talk about WebGPU and debugging is our validation layer, which we already kinda enabled right here in our engine when we're calling this configure debug callback, right, with this device set and captured error callback. So here I'm just going to break this shader, for example, because I want to showcase this. And here usually we would get this error, but our error would be output here, right? We would get this device create shader module. If you remember, we pass our shader to shader module and then we try to create it, and we got a line where the error is expected here, and it's some error regarding this letter here. Maybe we can do something here as well, or maybe break it here. We might get better error, just because I want to showcase this. And it mentioned it right here, doesn't know what to do with this. So that's one way of debugging it. But what I wanted to showcase is use of labels. Right? Why labels? Well, because right here we get an error, but we don't know what the error is associated with. And with WebGPU you can use labels, which will help you a lot, not just here, but later on you're going to see how they help you. So let's just go to our shader module util, and what I want to do is just create, well, basically a label, and I'm just going to make it like this by default. And then what I can do is in the scriptor, right, when we create it, we can actually here create a label. And what I'm going to do is just this small extension, because I don't want to like cast this every time. So what I'm going to do is just create a new folder, call it extensions, and here, so let's create a string extension. So we just need to make it static, right? And then we can create something like this: public static unsafe byte pointer, right? And we can say to byte pointer. And what I'm going to do is not this. I'm just going to say return byte pointer. Right? We can do this. So what I want to do is just I'm still going to do this Marshall thing, but this kind of static unsafe. These are extension methods if you're not familiar with C#, and they kind of allow you to create methods on sealed class. Let's say like that. I would suggest to look it up, but for now I'm just going to make use of it. And where did I change it? I changed it here. So I'm just going to say here, not here, actually here, label, and then to byte pointer. And I can do this here as well with the shape code. Some other name might be more appropriate, but it is what it is. So with this, if we pass it in, and we just have to pass it in from our untrained pipeline, where we create a shader module, right here, we could say unlit render pipeline shader. So why am I doing this? So if you try to debug it now, let's say, when you look at the validation error, let's see up, it's going to mention that label, right? So you can easily identify where the things went wrong because of the label. So I just wanted to mention that. The other thing that I wanted to mention is basically, what if we want to catch this earlier, right? This message, because right now it actually happens here, somewhere in before render method, right? When it tries to render, and it's actually caught by this general callback. So we can use what's called scopes and error scopes, and actually we can catch it a bit later, and it sort of acts like validation. So let's just go to our sampler shader module util, and I'm going to showcase how this works. So with these error scopes, and let's create it right here so that I can showcase it. We the idea of this is we can push errors on our scope, and then we can pop them. So you're going to see how it works. So we just need to say engine device, and then we pass error filter, and here we're actually expecting validation error. And then after this shader module, because we expect that the exception will happen here, internal exception to the WebGPU, but we can handle it. So we could say WebGPU device pop error scope, right? And it takes a callback, and that callback we can create it from, and the first argument is error type, the second argument is pointer, so message pointer, and the third parameter is user data. So we're just going to paste it in. Let's try it here, and for the user data I don't care about, so it's this parameter here, right? If you look at the device pop error scope, and maybe I should zoom in a bit. If you see it here, device, we have error callback and user data, and the error callback has 3 parameters. Last of them is the user data that we don't care about. If you want to paste something in, you can. It's kind of not really useful here. But error type, you can see here, we have it, and then the message pointer, so we're just going to cast. And we can say if error type, and now is of type validation, but we can also say something like this, if error type is not. And here the relevant are validation and out of memory, probably device lost as well, but not in this context. So we can say if there is no error, actually if there is an error because we're checking against no error, we can actually try to get that message, and this probably needs to be integer pointer. So we just need to cast it, and then we can console write it. But we can also handle this, right? So for example, this might be useful if you want to catch this validation, but let's say that in your engine, some user or user of your engine can create a custom shader module. So this might be a good way to handle it actually. So we can just throw here new invalid operation exception, and we can throw this message up. So if I try to run it now, right, you can see that it actually hit here. And what is our error, right? Well, it's this validation error that we got usually for the shader, right? It says here only train the pipeline shader module. We have this, right? This state that I have added, this is the error, and you get all the same stuff. So the point of using this is it's not just for shaders, right? Shader is easiest example to show, but this is for a validation error where you create a bind groups, when you create a pipeline, when you create a texture, and also the useful one is this out of memory, right? If you expect that you might run out of memory somewhere, it's good to use it. So I just wanted to mention this, and this is a good way of handling unexpected errors if you want to catch error before it hits some draw calls, right? Like it was the case before. So what I want to do now is obviously fix this. And let's try to do this because I'm going to need this. So what I want to do is just create a second render pipeline, and I'm going to call this unrendered untextured pipeline. The name is not super relevant, so it just means that I'm not going to assign texture to it. Only textured, but initialize. And what I want to do is, this is fine. Here, what I want to do is transform. What I want to do is, I'm not going to scale it, but translate it. Create translation. And I just want to do this. Actually, here it's fine, here it's fine, so I don't need anything, and I just want to draw it. So that we have two objects to draw, right? It's not really important what we draw as long as there are two objects. And here I'm just going to lock this scale for now. So I can say here temp. Sorry, temp. If I could write, that would be really good, but I'm just going to lock scale to something like 1.2. Okay, we have this. This is really not relevant. It's just something that I want to showcase. And here what I want to showcase is actually the tools, the outside tools that we can use, right? We covered a bit these tools that WebGPU gives us, but for debugging, you usually use GPU debuggers, and the popular one is RenderDoc for Linux and Windows machines. We're going to cover Mac in another video because this part might be too long. But the RenderDoc is a GPU debugger. What it means is it can capture a frame stack, and then you can inspect what happened during the frame, and that's what I wanted to do. So here I'm just going to launch it, and I'm just going to launch my game. So your game should be when you compile it in Bean Debug, right? .NET 8.0 or whatever you have, and then you find your executable to the game. And here, when I launch it, I'm going to get this, right? And it says capturing Vulkan. Why is that? Like we mentioned before, WebGPU runs on top of Vulkan. DirectX 12 on Windows, it can run on top of that, and on Mac it runs on top of Metal. So it says let's press F12. So I do recommend that you install RenderDoc. I'm going to leave the links in the description of the video. But here, if I try to see this capture, right? Here we have some stuff, and it's Vulkan stuff, right? Because it's capturing Vulkan. Right now we don't have WebGPU debugger, but you're going to have to figure stuff out, how it maps to Vulkan, DirectX 12 or Metal. Let's just look at the tools here. So we have this launch application which we used. Some of this is not that relevant, to be honest, right now. I'm just going to go through some of these tools which I really find useful, and the rest of them you can actually try on your own. But one of the important ones is texture viewer, and this is why I actually created two pipelines so that it's easier to see how it grows. So if you look at the texture output, here our command pass begins, right, and the color is cleared. And then we have this draw command, right? This is our first pipeline that we draw, and this is our second, right? So you can see here how WebGPU resolves this drawing, right? It just draws stuff on top of stuff. So I kind of wanted to mention that, but then also what you're going to find really useful here is mesh viewer as well, right? Because you can see here our mesh, and what's really useful with this tool is you can see output mesh as well. So here is output mesh, and then you can see all the vertices, right? If you remember our mesh, we had 4 vertices, but over 6 vertices, right? So this one and this one is duplicate, and they're the same. Should be, yeah, they are. And then this one and this one, right? And this corresponds exactly to what? To this here, right? We had our position, we had our color, and then our texture coordinates here, right? Color here is a 4 floats, and then position is a 3 floats. And when we were creating a pipeline, we actually had to describe it somewhere. Let's see, where did we describe it? Right, when we were creating, that's a good question. Pipeline layout descriptor. These are these ones. I think actually we described it in our not shader module, our render pipeline detail. Right here, right? We described this stuff. We had floated 2 times 3 times 4 next one, and then times 2. And you can see exactly that in this shader module, right? Sorry, in this mesh viewer. We have our input 0, which is our position, input 1, which is our color, and input 2, which is our texture coordinates. And we don't have any more inputs. But we also have out variables, and the out variables, so just ignore point size. For now, that's a constant. But position is, well, our position, right? Then we have output 1, which was our color, and then texture coordinates. And where do these come from? Well, we defined them in our shader, right? If you remember, if I go to our shader. So we had position, color, and texture coordinates right here. And here position is of type vector 4, but input is vector 3. And if we take a look at the RenderDoc, it's here, all right? It's 4 component vector. So I'm not going to spend too much time here right now, because further what I want to showcase is pipeline state. Actually, I haven't even drilled into this So here we have command bind pipeline, right? This corresponds to WebGPU bind pipeline. And then we have this descriptor sets. And what are descriptor sets? But those are bind groups, right? The objects between WebGPU and Vulkan don't have the same names, but they kinda act the same, right? So descriptor set, if you remember, we had bind group. And if we take a look at here, what do we have? We have one binding, and that's binding for buffer 242, so that's kinda useless name for us. But if you take a look at the contents, do you guess what contents might be? So if we take a look at here, this will correspond to this one, our transform matrix. So if you remember, we set our scale to 1.2, right? Right over here when we were creating scale matrix. So our value of that should be our scale matrix. And if I take a look at that here, right? After you drill to some buffer, right, you can check the contents. And now you can't see anything, right? But with RenderDoc, you can just ask for some other types. And here you might want to take a look at the documentation, but right now I just want to showcase this as floats, right? And this is our scale matrix, 1.2, 1.2, 1, 1, right? And this second descriptor set, right? It will be our descriptor sets that describes our texture and our sampler, right? If you remember, we had texture and then sampler, and we can verify that right over here in shader, right? Group 1 binding 0, we had texture, and group 1 binding 1 we had sampler. If we take a look at here, what is our binding 1? It's image view, right? Because it's actually texture view in WebGPU. Here it's image view, and if we check the contents of it, can we? No, I cannot. Here I can check the contents of a texture, right, that it has, and it's this one. And if you just check the alpha channel, it's our texture, right? Going back to this descriptor set, the second one is just a sample, right, that we have created, and I don't remember the values, but it says here filter linear, and then this edges modes, we had them on repeat. So what I'm trying to say is you're kind of going to have to, maybe it's not actually, maybe to rephrase it, maybe it's not a bad idea to take a bit look at the Vulkan and Vulkan types, even DirectX 12 types or metal types if you're on Mac, and to see how might WebGPU map to that. Because it's kind of very similar, right? All of these APIs are similar, there are some differences, but they're largely similar. Going further, so this combined bind vertex buffer, index buffer, I think that's clear, right? The vertex buffer, what's the content of vertex buffer? We had, can I do this actually? Float 3, let me just try. I can. We had float 3, right, for position, then float 4 for color, and float 2 for texture coordinates, and it should be 4 of them. And there are, right? Position here, color here, and then the data here. And then the index buffer, I think it's clear, it was something like 0, 1, 2. So I don't remember the format for short. I think it's just short. Should be enough. Right? 102, 132. Right? It corresponds exactly to our program, to this 102, 132. Yeah. So, with that said, let's go a bit further, and this is just draw command. It's clear what that is. But one other thing that I wanted to showcase is, I'm not going to spend too much here, but all resources, you can find all resources that are currently in use. Unfortunately, Vulkan doesn't support labels. Maybe it does. I don't remember. I haven't worked with Vulkan for a while, but at least our WebGPU labels are not showing here. But with DirectX, they will show, and we're going to be working with it a bit later. But for now, the other thing that's very important is this pipeline state. And the pipeline state is probably the most useful feature here, I would say, because you can see your vertex input, right? Our position, color, and texture coordinates. You can see here it will navigate you to mesh view. So let's just go to pipeline state. you can see the buffers in use, right? So this is our index buffer, this is our, I believe this is vertex buffer, and this is index buffer. And then you can see contents of it, right, which we already did kind of. But then we can go to vertex shader, and we can see descriptor sets that are in use. And here this is the 0, 1, the first one, and this is our buffer, right, 64. This is our transform buffer, and we go back to pipeline state, and we can see this one here, which is actually describing our image and our texture. But this is just pipeline layout, right? What describes pipeline layout, the ones in usage in vertex shader are actually shown here, and you can see this is our uniform buffer. We can also check the shader, but this is actually compiled to SPIR-V, and maybe the more useful one is GLSL, but as you can see, you're probably going to have to do some digging here, because this is not exactly very clear what's happening here. So here we don't have that much luck, because WGSL will get translated to SPIR-V, right, when it goes to Vulkan, so tough luck. So it just means that it's going to be harder to figure out how it got translated, but it is what it is. Then let's go further. These are some other shaders that we haven't used, like geometry shader here. Then going further, rasterizer. If you just want to check your rasterizer state, you can see all of the stuff here, like is it counterclockwise drawing? It is. Then we're not using too much of those. Fill mode solid, right? If you were drawing wireframe, it should probably say wireframe here. I don't want to waste too much time here, because we might use it in future a bit more. But let's go to fragment shader, because this one is the important one. And these three shaders, you can forget about them for now, because they're not supported by the WebGPU. But fragment shader is, and here you can see our resources that are used by fragment shader. It was our texture, right? And then it was our sampler. And here also you can check the shader, but like I said, it's not too useful. I think this is our texture, right? And then it's multiplied by in vector, which is our color. So if we check this 18, it should be defined. Where is it defined? It's good. It's kind of defined here. So it's a bit hard to translate it exactly, but you can probably take a look at the shade and then figure out what is happening. So not too useful, to be honest. But let's go further. What we can check, and then we can check fragment buffer. We can check our swap chain image, which what got drawn to it. So we can do same here, right, where we're drawing this thing. And you can see here, when I switch to this other pipeline, if we check the texture, it's this 1x1 texture that we used. So that's how can you use it in Vulkan. Luckily for us, with DirectX 12, we do actually get some benefits. So let's try this right now. So what I want to do is, I want to go here, and what I'm gonna do is our unlit render pipeline. Let's add label to it, right? String label, and then we can have some public string label property, and I'm just going to say get label is label, and I just want to do label. I don't care about this. Sorry. And when we create a pipeline, that over here, like pipeline layout, yeah, this is a good one. I'm just going to say label here, and I'm doing this because our vertex, our 4 parameters vertex function name. So we're not going to touch that. We're just going to create an optional parameter as last one. So just make sure to have this one, because that's important. And then we're just going to have label as the last optional parameter. String label. Alright, and if we go down, and we can actually now use it in the descriptor, we can say label. And then we can say label 2-byte pointer that we have created. And then let's go to our program. And so I'm going to say here only render pipeline. And then I can say untextured pipeline. If I try to run it, no, I don't need to run it, I just needed to build it. So let's go back here, launch. So if we take a look at the Vulkan here, the value of our pipeline is still graphics pipeline, right? In all of our resources, let's go to resource inspector. Here are graphics pipeline. Unfortunately, right now we don't have use of labels here, but let's try it with DirectX 12. I think you get where I'm aiming at. So let's change our render. Where are you? In our engine, where we used Vulkan. We're just going to change it to DirectX 12. And let's build it. Oh, let's quit render doc. And let's try to run it now. Right? Cycle F12, we capture the frame. So here you can immediately see that these codes are a bit different, right? Because we're debugging DirectX 12 now. So we're just going to go quickly through it, and I'm going to leave it to you to explore and figure stuff out. But what I wanted to mention here, if you take a look at the pipeline, so it has here this set pipeline, but it sets only render pipeline, right? And here it sets untextured only render pipeline. So you can use labels when you're working with DirectX 12. For Vulkan, for now, it's not the case. Maybe in future, I'm not sure if Vulkan supports label. Maybe it will. We'll have to see, but right now, maybe even through some extensions, I don't know. But right now, it actually does. And if you check our resources here, inspector, you can easily identify these pipelines right here. Only train the pipeline and only pipeline for texture, and we used it. We used this only pipeline default texture, and that's actually a texture. If I double click it, we can see this is this 1x1 default texture that we have created. I actually already had label assigned to it, but we can assign labels to buffers as well. Not all objects will translate well, and I'm going to show you what I mean, but let's just try to assign one of the buffers. Why not uniform buffer? Let's say string label, and then we're going to be similar. We have that, and then when we create it, here we can paste that label in. Oh, come on. Right here, let's go to definition. And in our descriptor, we can say label is label to string. 2-byte pointer, my bad. And if I try to build it, if I try to run, actually I need to assign it, right? So in our only trained pipeline, we were using it, I believe. So somewhere we had transform buffer right here, and we can now give it a label. And I'm just going to call it only render pipeline transform buffer. And now build it. Now we can debug it once again. So it's selected, which is perfect. Let's try to capture that frame. Let's see what I need to get. So if we go to all resources, right here, resource inspector, I should be able to find it, and there are two of them, right? Because we have two pipelines. We have only textured render pipeline and only render pipeline. But if you take a look at the contents here, float, or maybe I can do it like this. We can see that I here have 1.2 for our scale, and this is identity matrix, and then this is not relevant. It just, for some reason it created it, but the size here is actually 64, so it should be like this. Further, what we can observe here, right, is in this descriptor heaps, which are bind groups, right, in WebGPU. So if we take a look at the contents here, if I take a look at the descriptor, can I see buffer location? Render pipeline transform buffer. I can see it right here. So next, what I wanted to mention, this descriptor heaps kind of maps to WebGPU bind group, right? We have the second one here or here. If I take a look at the contents here, we should have an image, I believe, and we do have one, right? The image view, and then here it's sampler, right? What we had previously, but these are not going to map to DirectX 12. I believe they might not. Let's try it. So let's go to our render pipeline, and then we create a bind group. So create bind group layout. So we can actually edit, not here, my bad, but here descriptor. We can say label bind group layout. We can use this 2-byte pointer. So this is for layout, and then I want for bind group as well. So texture bind group, where is the descriptor? Ah, here it is. So here I already had the descriptor, only train the pipeline texture bind group. So if I debug it now, so we should have the descriptor here, but the thing is we don't have one. I believe in DirectX we're not going to see one. I catch it twice. It's fine. And it's still called descriptor heap, and I don't see anything that's using that layout. So what I wanted to mention, these labels might map to some object in DirectX 12 or Vulkan, but they don't have to, right? They might, they don't have to. There is no guarantee. So what is mapped, it's really helpful. What's not, it's still useful to have labels, because you can catch errors like we mentioned before, like this pop error stack or this global thing that was checking all the errors. It should be caught there. So it doesn't mean it doesn't map to DirectX 12 that you shouldn't use it. You should probably use the label. It's going to be easier to debug somewhere else, if not in this debugger. So one more thing that I wanted to mention is, while we're talking about labels, actually I don't want to quit this, I just want to quit the game. One more thing that I wanted to mention is we can have this kind of labels that we push to stack, and I'm going to show you what I mean right now. So if we go to our program, and let me just check my notes because I don't know this by heart, the name of it, but we have this kind of idea of pushing labels, and I'm just going to need unsafe here because this is using pointers. But what we can do here is I can say engine WebGPU and then render pass encoder, push debug group. And here we need render pass encoder, and I believe it was called kernel render pass encoder. So just double check if this is public. I think it should be public. And we can say here only render pipeline. The name is not relevant, but what we can say here, we can pop this group, and then we can paste this group again. And you're going to see where I'm aiming it with this. So we can say here untextured, or draw, you know what, let's use untextured. So where I'm aiming with this is, let's just build it, and let's try to run it again. And this is kind of useful feature. I like this really a lot. And it's not supported in Vulkan, but in DirectX it is. And you can see here only train the pipeline. And if I expand it here, you can see this draw, right, call, and then this draw call, right? And what is this drawing? Well, it's drawing, this is our first draw call, which actually draws, let's see texture viewer, which draws this, and then we have this second one, which draws this white thing, right? And it corresponds exactly to this here, right? Because we wrapped this into this, but we can also say something like draw calls, right? And if I do this and remove it here, and if I just build it, so I need to relaunch. You can see how you can use these labels to actually to have like these expandable regions, or better yet, you can have regions of what is drawn in that region. So I'm not sure how to explain, I got lost a bit here, but you can see what I'm aiming at, right? These draw calls, right? You can push and pop these labels, and you will have these labels in frame stack over here. What I wanted to showcase a bit further is we're almost done here. I don't have too much to showcase now, so I'm just going to return this, right? And this doesn't have to be just on render pass like it's here, so it can be on compute pass, but on textured. We can also pass it for our command encoder, which was in our engine. So we could say something like start render pass or something like this. So let's try it here. When we create command encoder, we can say WebGPU command encoder push debug group. We can say here render pass, right? And then we can pop it once we've finished the command encoder here. Pop. Right. If I try to build it, let's go here. So this is really useful because here, if you check now, we have render pass, but we also within the render pass, we have these spaces for only render pipeline and untextured render pipeline. So this is kind of hierarchical, right? You can push stuff, and it's not just flat, right? So with that said, I think we're done. So yeah, I'm just going to recap quickly, and I need to mention, because I'm just going to do another video, which will be complementary video to this for Mac. And it's going to be very shorter because I'm not going to go all the details. I'm just going to go through Mac Debugger. What I wanted to mention here, this is not the only GPU debugger, right? You can use proprietary GPU debuggers, like NVIDIA has one, AMD has one, Intel has one, and you should use them. I just wanted to cover Underdog because it should be available for everyone who is on Linux or Windows. On Mac, it's not available. There we will use actually Mac tools, which are specific for Mac. But aside from this one, I will leave links in the description of the video. And if you want to try them, you can try NVIDIA, Intel, or AMD ones, depending on what you have, right? If you have some Radeon GPU, you're going to use the AMD tools. If you have NVIDIA, you're going to use NVIDIA ones. If you have laptops, you can use multiple ones depending on your setup, because you're usually going to have integrated GPU, and then you might have dedicated one, and they don't have to be from the same manufacturer, right? So I want you to check that. And regarding this, so I want you to actually get familiar with this tool. So just go to the tool here and try to see everything that you have here, like API inspector we already checked, statistic viewer, that's not important right now for our game, but you can probably find something that's interesting. Right now I cannot. So yeah, just try to play with this and then try to get some other tools. And this will become more useful in the future, and I'm going to try to use this more in the future, especially the render doc, which should be available to most of you. And with that said, that's it. My advice is try to actually use both Vulkan and DirectX 12 and try to install more GPU tools than just one, because you might get some features that you will find a bit better in the other one, or you might find some feature that's not available in your GPU debugger. Here, I think Vulkan kind of maps some stuff a bit better from the WebGPU, but then again, then DirectX 12 has labels, and so I would suggest try to switch between them when you're debugging. So that's it for this video. If you liked it, maybe leave a comment, subscribe, and until next time. And the next time I'm just going to do a shorter video, hopefully next week, on Mac Debugger. So that's it. All the best.